I am Sarang Rao. I am principal with Gulfstream Partners, and we've been working with the SPE London as well as other SPE chapters for in organizing this hackathon. And as part of the effort, we've also volunteered to conduct boot camps on R and possible use of R through the Geo Hackathon, especially for grappling with data and um, running data analysis, data science related processes, graphing, visualization, all of that. So just the general structure, there currently are 2 boot camps planned for R. We will, depending on the feedback we get from you guys and how much ground we are able to cover, might add a 3rd one and have some Q&A sessions directly on Discord for video or text, depending on what the responses is and the Q&A we get. So before we start, on behalf of Gulfstream, as well as the whole team for Energy Geo Hackathon, it's a very warm thanks to all our sponsors, Kalida Aqua, Eavor, Geolog, Halliburton, Integra, Oilfield International, TNO, Seismos, Untapped Energy, GEODE, Packers Plus, and OMB Petrom. If I've missed any, my apologies. We'll try and make up for it during the next session. So as I said, my name is Sarang Rao. I'm a principal. I run a couple of consultancies. One primarily is Gulfstream Partners, and the second one is Theo. You can find us on www.gulfstream.partners. As I think I flipped the chronology, but just to recap the bootcamp schedule, this was part of the previous presentation as well, but never hurts to revise date and timelines. So we are on session number 3, which is Introduction to R Part 1. Following that, we're going to have Introduction to the Digital Hub from Integra on 26th. Introduction to Machine Learning. I think that would be primarily based on Python for 1 and 2. On 27th and 28th, and then 29th, we are going to do a second bootcamp for R, which would delve into more advanced topics, analytics, machine learning, reporting and dashboarding using frameworks like Shiny. Following on from that, in the week on 1st of November, we're going to have another machine learning example from Halliburton, or a suite of sessions from Halliburton for doing machine learning, text analysis, and data to insights with visualization and dashboard. There would be a data modeling session by GEODE, the Digital Hub, end-to-end data science on the Integra platform. And then finally, I think the introduction to the hackathon modeling, where we would go into the high fidelity geothermal simulator framework, or DARTS, which was mentioned yesterday in the geothermal introduction session. As a background, on our teams, for Gulfstream, I am supported, or I work alongside Vladimir. He's also a co-principal, and we work very closely with Tim Lyons, who we also know as the program chair for SPE London, and he's the managing partner for Oilfield International. I think Gulfstream primarily stemmed from a focus in financial services, banking, and investments, which had some overlap on energy. But with Oilfield International, I think we're taking that deeper and creating offerings and services for the energy sector, both for oil and gas and renewables. So what do we do as Gulfstream? We provide bespoke digital solutions. A large part of the focus is on quantitative analytics, automation, and efficiency projects, and transformation and innovation strategy consulting. As I said, sector-wise, our primary focus is on banking, energy, and private equity, or hedge funds, broadly all buy sides. Technology-wise, we work across the stack. A large part of the work we're doing is on bringing in low-code or no-code automations and data science capabilities to teams and organizations so that they can accelerate their data and digital discovery and transformation processes without having a need to quite heavily focus on investing in a completely new stack or retraining existing human resource. Similarly, Oilfield International, Tim is a veteran in the space. He's been working on a whole suite of offerings, everything from valuation and due diligence related work, advisory on financing and capital market processes, which is offered through a partnership with USIL. Also support and work on development of fields and assets and commercial assessments and negotiation and agreements. You can find both website links on the presentation. So if you'd like to go in and explore more details or get in touch, it's there. So now coming into the crux of the matter, introduction to R. What the general format of the bootcamp or this particular session is going to be is more heavily structured towards coding. So the PowerPoint element or the presentation element will finish in another 4 or 5 slides. We will move over to IDE environment, particularly from RStudio. We quite like that within Gulfstream as well as Geo. And I'll go over why we prefer RStudio and what other options are there in the market. We'll also discuss what are the advantages we feel of using R or an RStudio related ecosystem within data analysis. There's a huge focus on Python in the field, and both R and Python, there's sometimes almost a cult-like following and debates about which one is better. We work across both technologies, and I feel that each of them bring their unique strength to the process. And it should not be Python or R as a conversation, but like given the tools and environments we have and cross compatibility, it would be Python and R. That would be an ideal scenario ahead. So topics for this particular bootcamp, we'll cover basic data type in R, operations, data structures, installing and loading libraries or packages, which form the backbone of the strength of R, with over 10,000 packages that have been released on CRAN, and they cover every application of statistical and data analytics that you can think of, everything from pharmacology, insurance, banking, quantitative, sociology, any place you can think of where data analysis, especially heavily leaning towards statistics is involved. You would find the R package doing that. With the recent adoption of ML and AI frameworks, a large number of these libraries have been ported to work alongside R. So you can have things like TensorFlow or everything that Spark has to offer, which can be called upon and worked from our environments. And I think those would be the topics for the second or the third bootcamp, depending on the interest and the complexity that we get to. So what is R? I think R started off as an open source implementation done by a couple of professors in New Zealand. The implementation was based on software called as S, developed by Bell Labs back in the 1970s. And it was very heavily used in data and statistical analysis. I think R worked or contributed to majorly in expansion and use of statistical computing within academia and in the industry after it was created as an open source implementation and released out in the wild. Huge number of research papers or research work is carried out and supported through data modeling and publication done in R. There are some really good tools which allow for a single environment development of your analysis, your text output, all integrated into one file, like Markdown or R Markdown, which can be rendered and parameterized quite easily. So I think, especially from a perspective of reproducible research, I think R offers huge amount of advantages in this field. And that's one of the main reasons why we love to use R. A large amount of analysis that we've realized is never a one-time endeavor. So you'd need to run research in an iterative fashion. Once it is done, you would need to share it with other people. They need to be able to reproduce your results from scratch or from whatever raw data you've used to create that research. Having the ability to read through what the coding or analysis has been. And so R offers that quite wonderfully. It offers huge amount of packages and functions that can do anything or everything from data analysis, which is exploratory data analysis, statistical analysis, modeling, simulation, risk modeling, solving optimization problem, doing geospatial data analysis and modeling, implementing machine learning algorithms, everything from a random forest to a TensorFlow, all are available within the framework. So it offers great amount of flexibility and is supported by a great community. It's very active, and most questions you run into either technical or computational. If you go and search on Stack Overflow, there'd be somebody who else has come across that problem and can very intelligently help you solve it. If it's a completely novel problem, you would still have people in the community who can jump in and contribute on guiding you or even helping you solve it through code pieces. So as I was saying, what we use R for quite majorly is the ability to create dashboards or independent piece of analysis. And I think even for the geothermal hackathon, that's a good example where something like R can be very powerful. Python, if you're coming from computer science or a programming background is a wonderful language. It sits very well with programmers' way of thinking and looking at the world. But R has its unique advantages as well as a handicap depending on where you're coming from. It doesn't follow the traditional programming paradigm to the T. So a lot of software engineers find R to be very unwieldy, but for people who are more closely aligned with business and focus more on data and analytics, or statisticians, they find R very useful because it's structured in an intuitive way and operates um, very closely aligned to how data analysts or statisticians or researchers think about analyzing data and producing research rather than creating large scale production grade or enterprise grade software applications. So there is a bridge, or there is a gap between using R on large scale production grade systems, but uh, with a lot of the work that companies like RStudio or even Microsoft is doing in embedding R and improving its capability, there are a lot of new improvements that are coming in. One of the restrictions of R is it's RAM based, or it's primarily runs all the calculation in memory. So when you're working on very large data sets that probably run into a few gigabytes or terabytes, R will struggle because you can't bring all of that into memory unless you have a amazingly expensive machine, which I don't suppose most of us do. But there are implementations of things like Apache Arrow, which is unified data frame structure, which can be called for by different languages in memory without having to create a copy of cache and pointers. So it allows you to run analysis on a data frame from Python as well as R or C by calling the same object and without having to make any copy in the different environments. So there are things like that. There's also work that has happened on creating some level of multi-threadedness. R is not inherently multi-threaded. So there have been improvisations to bring some of the capability of computers with or computing power with distributed computation, which can be used within R through some of the advanced packages. And the other good thing in R is piping, which is provided by packages like dplyr, and we'll go over those examples in a bit, which makes writing functions easy. And more importantly than writing functions, it makes reading functions easier to understand. Because whenever we write a piece of code from a research or analysis perspective, there's at least one other person who's going to be reading that code. And that is the future you. It might be that if you've written a piece of work only for your own consumption, but when you come back to it in 6 months' time, and if you've written a very nested function, it makes it really difficult to understand what it is doing because you have to read the function inside out. Piping changes that paradigm in a sense that it reformats your function writing inside out. So you start by normal steps of take this data, filter it in some way, group it by certain parameters, and run a summary analysis. If you run that in a regular function paradigm, it would usually be the outermost is your run your summaries, and then you have to step back with each bracket. Piping allows you to get rid of it and write and read the code in a more natural flow. So there are a bunch of primary links that I would point to for resources. First one is the CRAN-R website. It's the place where R resides, the R engine itself. You can go here. We had provided links to this in the Discord server. It provides you a direct link to places, to the page from where you can download the R engine itself for Linux, Windows, or Mac. The second piece is RStudio. RStudio is a company that has designed and a interactive development environment for people who use R. It has a bunch of features that a regular computer programmer would be used to or would want from things like Microsoft Studio or Eclipse or one of these other or PyCharm. So they've created a development environment which is very well suited for how R operates. Along with that, they've also contributed immensely through people like Hadley Wickham and the whole team that's supporting Shiny and other packages that RStudio or Hadley and his Tidyverse team works on. So you can find a link to that from this web link. We are going to use some data for this particular exercise. I have used data from Oil and Gas Authority of UK. There's always some default data set like a motor car data or petals data that usually comes packaged with these softwares, open softwares. But I thought, speaking at Society of Petroleum Engineers, oil and gas data might be more relatable as an example set. I've also provided links here to cheat sheets. These are cheat sheets that a lot of people have, who work on different projects have put together. So one way is obviously going through the entire documentation of all of these packages, understanding how they work. The second option is having a cheat sheet just to look over how to operate and make use of different packages and functions they provide. So in here, you can have a whole list of cheat sheets that have been created by people who work for RStudio, as well as there are a bunch of them which have been contributed by the community. So it's a good one-stop shop for having access to most of your questions answered. So that said, before we jump into the coding side of things and start taking a look at R, are there any immediate questions, feedbacks that any of you have? I want to make it more of a interactive session rather than me talking and just showing, walking across some pieces of codes that I've written. So as long as it doesn't overwhelm with too many requests coming in, please post questions that you have in the chat box, and somebody from the team can help prompt them so that we can drive the conversation of topics we are covering and answer any questions on the go.
Hey, Sarang, it's Tim. I've read one or two of the questions in the chat box, and I think people are a little bit concerned about whether they'll have enough skill or technique after attending your lecture course to be able to do something with the hackathon. Do you think that if they attend the 2 or 3 sessions that you're going to provide, that they'll have enough to do something useful?
If they think that they could work with Python and use Python within the hackathon for solving the problem, I'm pretty sure they can use R. They work very close to each other. We would be providing active support on Discord. So if there are any questions, we can directly relate it to either the data set which has been made available for the hackathon. If they have questions relating to how to do something, we can answer them there. So yes, I would suggest let's walk through the bootcamp in terms of looking at how it functions, and if depending on what the feedback is, we can either add 1 or 2 more sessions. We are always available on Discord chat or audio calls to answer questions, as long as they don't become very mundane and haven't been tried to answer with the existing resources.
There's one interesting question that has come through, which is, are the syntaxes of R and Python similar but not the same? In other words, could you get confused by learning Python and then trying to jump across to R? I mean, would you advise people who know neither language to fix on one, or would you say that they're sufficiently different that they won't get confused with their syntaxes?
I don't think you would get confused. So I use Python and R both in the field of work that we operate in. And which one we use is mostly dictated by how quickly we need to respond back and to what scale are we making a piece of analysis or research. So to give you an example, if we are creating and deploying a bunch of machine learning algorithms that need to be called in on a website for doing live scoring, we do that in Python because Python supports that infrastructure because it's a general purpose computing language. But if, let's say, we are supporting a due diligence piece on a particular private equity transaction we are supporting, and we have a bunch of transaction data that we need to analyze, and we need to make it available to the team for analysis and pricing or underwriting. We prefer to do that in R, because with R, we can make a Shiny application, we can make it talk to a R markdown through which you can very easily render a Word doc or a PDF, or even with R, we can populate a PowerPoint deck. So every time analyst needs to do some sensitivity analysis and then re-update a bunch of PowerPoint decks or his investment memo or piece of research work, it's much easier to render that in R than Python. So this.
Can I just clarify then, because I think you probably answered one of the questions just come up. So if people chose they could do everything for the hackathon in R, and you need to correct me if I'm wrong, and also because of the power of Shiny, they could also prepare their PowerPoint presentation at the same time. They could also, for that example, put a website together if they wanted the examiners to look at the website that they created. They could do all that within R and R Shiny. Is that correct?
Yes. Yes.
Okay.
So you don't need to jump. So all your so in a Python analogy, it would be like, so R Markdown is similar to what you would get with a Jupyter notebook. So R Markdown behaves similar to what a Jupyter notebook does, but it also allows you to then, from within the RStudio environment, you can create a website which would be like a Dash app for people who know Python. So I think Dash, to that extent, to some extent, actually took inspiration from Shiny. Similarly, what you have with pandas was inspired by data frames in R, because Python originally did not have it. So yes, there are a lot of these things which have cross-pollinated from one technology to the other. And if you can do something in one, most likely the answer is you can do it in the second as well. Also, the good thing with the RStudio environment is you can run Python in RStudio. You can, if you have a bunch of Python scripts or functions that you've written, you can call that and run it within in RStudio on the same data set. So you can have a bunch of Python functions to which you can pass data, get the output, and then do the rest of your analysis in R, or vice versa, where you can do a bunch of analysis in R and then call that output in Python through wrappers.
Yeah, that's excellent. Yeah, and also quite important because, if, for example, if people want to access Dart through Python, then they just stick it with inside the RStudio frame, and then the data are then available to R. I think probably I should stop asking you questions and let you get on. If anything else pops up in the chat, I'll maybe ping you at the next available opportunity. Thanks very much, Sarang. Over to you again.
Okay, thank you. So let's jump into the basics. So to start off, R has 6 basic data types. There's a numerical value, integer, a logical value, character, a complex number, and a raw. Let's not worry so much with raw, because 99.99% of the cases that you deal with, you're never going to come across a need for using a complex number or raw in your analysis. Maybe given that this is an engineering audience, you might be more exposed to situations where you need to use complex data type, but I haven't, and I've been using R for over 10 years. So I'll first give you a lay of the land. We had provided a link to installing RStudio and R. So what you see in front of you right now is RStudio IDE environment. This environment is essentially broken down into 4 major pieces. On the top left, you see tabs which show all the different scripts that you have written or you can write. You can create a new one by going into the plus sheet icon, and you have access to write all of these different kind of pre-populated script templates. So you can write an R script or a Python script or a SQL script, and you can directly fire up a template for a Shiny application or a Plumber API, or something for doing a presentation or documentation. All of those are available. On the top right-hand side section, you see 4 tabs. First one being environment. Within here, you can see all the variables that your R environment currently has active and loaded in memory. Right now, because we've just started everything, there's nothing in memory. But as we go along, you will see environment being populated by every new element that we add in the process of our bootcamp. There is a section where you can see all the history of everything that you've run. So if there's something that you've run and you need to go back and call it, you can see that in the history tab. Let me just clear it up. Okay. The connections is another good, quick widget or tool that RStudio offers. Within that, it offers you ability to connect to database directly through pre-configured data connection. So you just need to download and install the ODBC package, which is as easy as just clicking yes, and R will in the background grab the relevant packages from CRAN and install it. So also you can do it for a Spark connection. There is a new tab which RStudio has added called tutorials. It has a learner package which they've configured and walks you through basic steps of how to learn and walk through different elements of R, everything from working on basic numbers to doing advanced data wrangling. On the bottom left side, you see the console. This is the R's engine console, which you would see if you just fire up R independently. So R as such is an engine which is running in the background, and RStudio IDE is something that sits on top and wraps it and provides a window into that. You also have access to your terminal window and a list of jobs that have been run or are running in the background. Bottom right-hand side, you get access to the lists. By default, it will start into what you call as a working directory. So every time we create a, we open up RStudio. Let's just open up a new instance. It will offer you two options. One, either to open into a project space where all your relevant project related files, scripts, everything is saved, or it will open up in a blank default directory. So as you can see here, this is just a blank default directory. There are no projects. If I click open, it just provides me with a basic default of a blank working directory state that I've last opened up in. Oops. Let's close that. It also, the next tab allows you to have access to all the plots that you've done. The packages tab gives you a list of all the packages that you have installed on your system. Every place that you see a tick box in next to the package, it means that package is loaded in memory and is available for you to run any functions on. You have again a helper section and a viewer section. Help again provides you with a quick access to all the different tabs or links for everything related to R and RStudio. So you have R resources, studio manuals, reference to all the packages and miscellaneous information. So with that said, let's get going. So as you see, on the bottom side is our R console, and we can directly run commands in here. So if you come here and start typing in calculations, saying something as basic as 1 + 2, it gives you the answer in the next row 3. But now if you want to keep this calculation in memory or create a script that you're going to use repeatedly, that is when you would go up and create a script document, something like this. And when you can run the same command up top by pressing Control Enter, and it gives the same result. You can see in the bottom part of the console, you can see R executing it. So similar to that, you can do all your mathematical operations. Some interesting bits. Variables like pi or e have a default value, and R would recognize that. So it's very important that you do not override that, because it would override that on the environment level for all other calls. So if there's another piece of code where you're using or calling pi, but you mean the actual pi value, that would be overridden when you do something like this. So if I say pi is equal to 5, and then I do pi times 7, now you get 35 instead of 21.99115. So, but all of this is just a glorified calculator. So in terms of doing actual work, you would need to use variables and have the ability to assign. In R, they use an arrow. Somebody probably is a big fan of Cupids, but they use arrow to assign values or an equal to. So both have effectively the same result. So we did num1 and num2, and if we do sum num equals num1 times num2, The answer is 140. Now, obviously, there's an error here because a sum is a summation and not a multiplication. But you can look at a class of any variable by calling that variable and wrapping it in the class function. The second type of variables are characters, which you can see. Third being a Boolean. For a Boolean, it will respond to true or just the capital T or a capital F, either ways. But if you do title case true or a lower case true, you'd get an error saying object not found because it's not recognized as a valid Boolean value. So moving on from individual scalar values or individual unit values to broader vectors, the data structures you have available to work with within R are primarily vectors. It could be a single value vector like the ones we saw before, or it can have multiple values within them. You can have matrices and arrays, a list, and data frame. So those are the four primary data structure types which R works in. And you can define a matrix just by providing the bunch of values. So here we are calling in the matrix function saying create a matrix with values 1 to 8 and by 2 rows, a 2-row matrix, and make it by row, which means it will start filling in the row first. And if you make that false, you get a matrix where it's populated column wise instead of row wise. So you have that level of control. You can run matrix operations like adding to matrix. Now here it's given me a warning message, but it has still run the calculation. And why the reason why it has done it is we've supplied 9 values and it does not fit neatly into a 2-row matrix. So what it is saying is the data length does not match the number of rows that you are asking for. And what R does in such a case is a process of recycling. So it will take the first value, or it will begin from the start for any missing values that it encounters. So as you can see, it went through 1, 2, 3, 4, 5, 6, 7, 8, 9, and then for the last value of the second row of the matrix, it picked up 1 again. So it's something very small, but very important to take note of, that R will allow you to run such things. It will not give error. It will provide a warning message, but it will still run the code for you. So you have to find,
an important question. So we've been asked whether or not these scripts can be available for people to practice on after your
yes. So all of the scripts will be made available on both on the Discord server as well as do we have any other place where we are providing a repository of materials?
Well, I mean, Orfield's got a GitHub. We could put something on there if you like. Do you want to create a new instance in there?
Okay.
On GitHub?
Yeah, we can put it there.
All right. Well, okay. Well, we'll work on that. I didn't. Yeah. Sorry, I didn't. What's your first name? Di Benedetto. Anyway, so we'll have it sorted out for you.
Okay. Yeah. So all of this, all the scripts would be made available for this bootcamp, the next bootcamp, and if there are any questions that come in which fall in the category of frequently asked questions or something that's boosted or repeatedly asked, we write up scripts or help for you on Discord. So that should be your place to go and find stuff. Okay. So yeah, coming back, you can again similar to individual operations, you could also do similar operation with a matrix of like multiplication, inversion, division, addition, subtraction. All of that is available. Graduating on from matrices, we come to arrays. You can similar to arrays, similar to matrix, you could also create arrays where let's work with this example of creating a array of 1 to 16 values, and the way you can create a dimension of that array. So there are two possible ways I can, or you can do that. So let's take this. So not now. So if we go array 1, gets array 1 to 16. There is your single dimension array of 16 values. Now within the array function call, and I guess this is one of the good things about using RStudio, is if you call a function and hit tab, it will give you all the variables the function expects or has, both as an option or as compulsory value. So data equals 1:16 that we've provided. Dim is essentially the dimensions that we want to create the array across, and we can also provide names for those dimensions. So now if we recut that array as a 242 array, what you would end up getting is array which has 2 rows, 4 columns, and two arrays. So you are able to create all of that through just one call. As we just said, we can also specify matrix. That's our matrix. So once if you are creating a matrix, you can also, like the array, you can also pass row names or column names for a given matrix, and then call intersection. So you can do that by providing the matrix name and then calling the relevant row and column within a square bracket. So that gives you, I think it's very similar to how Python would work or other softwares handle something of this sort. The next level is a list. Now, the thing with a matrix or an array is it takes only one kind of value. Matrix is will obviously be numerical, but within an array, you can have it as a text or as numerical, but you can't have mixed. What list allows you to do is list can be made up of different kinds of elements. So if we create a list with the first array or the first list within it being characters, the second is Boolean, and the third is just numbers, or actually the third one is a matrix, we can do all of that and store it in one object. You know, like array, we can assign names to each of those objects so that calling them for downstream analysis becomes easier. So if we look at this, down at the bottom, you can see list now contains animals, evaluations, and number matrix. And I guess the last piece, and probably one of the most powerful in R, is a data frame. A data frame is a table that you can work with. And a very easy way of creating a data frame is calling the data frame function, providing column names, and passing values for those columns. And if you see here, there's a class for it, data frame. Similar to data frame, there are other classes which have been created as derivatives or hybrids of data frame, like data.table or tables, which are special cases or special implementation of a data frame. So the class call allows you to see what kind of what class a given object belongs to. The structure allows you to dig in a little deeper and look at what it is composed of. So where class only told us that df1 is a data frame, str, a short form for structure, tells you what it is made up of. So it shows you that it's a data frame with 3 columns, and first column is a character, the other 2 are numbers, and brief skim into initial values. Now, beyond this, let's come to the mainstay of R, which is statistical analysis, and it is as simple as calling a function and passing the data frame or the column value. So you can do find a mean of a column height just by saying mean data frame 1 and dollar height. So also to iterate the point, and I know it's very easy for me to just click over something that's written, but if you see here, when you type in mean and hit tab, it allows you to provide additional information. It gives you an option to have access to all the active variables in the environment and the primary input that function is looking for. So we can say df1, and if I type in dollar, it also provides me with a quick access to all the column names. So if first was height, let's call in width, and that's 30.9. If you want to run a summary analysis and don't want to call every standard statistics function that you need to for understanding different distributions or values for a given number set, you can call in the summary function, and when you run it, you get a high-level overview of what's the minimum, maximum, the first quartile, median, mean, and third quartile. So it gives you a good idea of the distribution of values you're looking across for your analysis. Then simple things like if you want to get if you want to filter data and have a more nuanced analysis, you can call it by saying data frame $1, the column against which you want to filter. And in this particular case, it's a number. So I want to see everything that is more than 15. So data frame $1 height greater than 15. And if I run this, it will run a Boolean condition on that column and come back with a list of an array output of where things are true or false. Now, if I actually want to see the data frame underneath it, and I want to get access to the data, what we need to do is provide for the data frame name, and within that call our filter function. So as we know that data frame or array work on a numerical call within a square parenthesis. So the classic way of calling a data frame, if you want to look at specific columns or rows, the way you would do it is within the square data frame, use the first part for anything related to rows, the second part for anything related to the columns. So within data frame 1, if we pass the Go. Data frame 1 and copy paste this condition, Control C. Put a comma and say, give me back all columns. If we run this, it gives us the output of the table that matches values where height is more than 15. You can make it more complex by adding other conditions where, let's say, if you also want to put in width is less than, let's say, 33. Now you get a smaller data set. So it allows you a fairly deep level of control. Similarly, ordering data set. So if you have a data table and you want to order it by any particular variable or column, you could do that. You can dictate whether it is ascending or descending. You can also combine data sets very easily. So here we've created, sorry, I forgot to mention this point, but in the environment, every time we create a new object, it gets listed on the top right-hand side. So let me remove df2 that we just created. Okay, so df2 isn't present right now in the environment, and when we create that data either through an import or directly through input, you can see the basic structure of the data here. You can click on the table, get a read through of what the data is underneath it. So on the top side, you can see all the lists or the datas. In the bottom part, you can see values that you've created and what it currently holds. So it's makes the process of troubleshooting or analysis much easier because you have a live view into most active variables that are, or all active variables that are in memory.
Sarang, I know you've got a program to go through. I've just got this question because it seems like it's the kind of thing that might be interesting to show how it can be done. So you've got two arrays now of 10 observations of 3 variables. I wonder sometime during the end of this thing, you can show whether or not the two populations, what the probability is the two populations, so the two sample sets come from the same population.
Okay.
So I know it's one level more complex, but since you're doing this, you've got 2 sets. Why not? That's the kind of thing we ought to be looking to do. And saying,
yes. So I think so those kind of questions we have for the second session.
Okay.
Yeah. So in the second sessions, we are going to go through a bunch of machine learning algorithms. We're going to go through advanced statistical analysis and dashboarding and reporting. Okay. So other common things that you would want to do in data analysis is do grouped analysis. And as we move to, so previously in the presentation, I spoke about piping operators. Now, earlier up here, when we wanted to run the mean or of any particular variable, we had to do a inside out approach where you have to first call the function that you want to run and then pass the data inside of it. And if there are layers of it, it becomes confusing for an analyst when you revisit it after some point of time. What R allows you, especially through applications or packages like dplyr, is writing your code in a piping methodology. So what you see here is I have taking a data frame and piping it through this operator of a percentage greater than percentage, and then providing it to the next function. So what we're doing here is we're saying, take my data frame called df2, group that data by the column model, and then summarize that data by providing me the mean height, which is calculated as mean of the height column. And if we run this, the output we get is a nice elegant table which shows you that by model, what are the mean heights. So I think we'll go a bit more in details of this. But outside of this last part, everything that we did up top is how base R operates. It is easy, but once you start scripting complex functions or a complex script, it does become more and more challenging if you have to keep track of stuff. And that is where the wonderful community and R comes in its own power of having a bunch or a plethora of packages that solve targeted problems or issues. And one such is a group of packages called as the tidyverse. The link to it is in the presentation. But tidyverse is effectively aggregation of around 7 to 8 packages, and it provides for everything from handling time series objects to using piping for programming paradigm, handling strings, and a whole host of functions. So it's something I would definitely recommend you install. Installing packages can be done simply by going into tools, install packages, and within here you have access to repository, the CRAN repository, in which you can search for any package you want. So if, let's say, there's this one called data.table, I can come in and say install. So right now it's saying I already have it installed. Do I want to override it or update that? So I'm going to hit cancel. But that's one easy way of installing. If not, you can also call it through a script or command for install.packages and the name of the package. You can install a series of packages by passing them as a list within the install package command. And once the packages are installed, you need to load them in memory using this function called library. All that library does is it opens up the package and makes it available, all the functions available to R to implement. So I think we should have all of these already running, but let's try and let's do a new one just for a quick demo. Let's check leaflet. We can install that. So it's grabbing leaflet and it's grabbing all the related dependencies from CRAN and installing them into the system. And that's done. So now all we need to do, if we want to use anything from the leaflet library, is call it. and all the functions or capabilities of Leaflet are now available within R or within your active environment for using. So now let's delve a little deeper into the data wrangling element of R. And for that, what I've done is I went to the oil and gas website of Oil and Gas Authority of UK website, and I downloaded the file which provides for the field equity shares as of June 2021 across all the different operators. This file, just as a recap, let's open it up. Let's say, okay, view file. Let's open up Excel and see what this file is. So what this provides for is it has the name of the field, the organization that has equity ownership in it, the percentage of holding, whether they are an operator or not, what was the start date, what's the end date, and whether it is current or not. So a very basic data set, but I think something all of us can relate to. So RStudio allows for easy ways of importing data. You can go into import dataset up top. From there, choose Excel. It provides you with a browser window. You can go in, select the file. What it will do is it will open up the first default worksheet which Excel has. You have the ability to control and be more articulate about a particular sheet that you would want to go to. You can also specify a specific name range, and we can also rename the variable after, like, what do you want to call it after it's loaded up. So I don't think that's very useful. We probably can just get away with calling it equity field equity shares. Now this particular sheet, the top two rows are not very useful because it just has descriptive data. All the relevant information is actually starting from row 3. So you can come in and say, start from row 3. Actually, no, start from row 2. And so now it has picked up the headers correctly. What it also neatly does for you is it tries to predict what value you are loading up. So in this particular date where it is start date and end date, you can default it to choose or specify that you are looking at a date value, because sometimes what happens is if you're loading up date value from Excel, it will load it up as a numerical, which makes then processing a little bit of a headache because you need to then go back and convert it. So RStudio is just as an import package, handles some of these things for you. And what it has done, if you see at the bottom, is it's loaded up the relevant read Excel library, which creates all the functionality for reading Excel files. And it has given you the commands for directly loading it through a script instead of the point and click option. So next time around, if you're using it as a script, you don't need to come in and physically import the data set. You can have it just as a command that's pre-written for you, and you can load the data directly from there. So let's go ahead and load it up. Sorry, jumped. Okay, so here the data is uploaded into the memory you can see it pop up here on the top left-hand side. You can see the field equity shares as a data set or as a table that has been loaded into the system. We can look at its class. Now here you see it has uploaded it as with the hybrids or additional table features of a tibble as well as a tibble data frame instead of a plain data frame. We can also look through a bit of the details of what the tibble or the data frame is composed of. There is also this very useful command called skim, which is provided through the skimmer package that allows us a deeper look into the data frame. So if we look at it, it provides a much more useful analysis of the data set. It gives you the name of the data set, number of rows, number of columns, how many character columns, how many numeric, how many date. And then it also gives you a breakdown of how many missing values are there, what's the completion rate, the min and max of each, number of empty, number of unique values, white spaces, if it has come across any. For all the numeric values, it gives you a summary of missing values, completion rate, a histogram of the distribution of data. And then for date variables, it provides a similar analysis around the dates of what's the min, max, and number of unique values. So now what the first thing that would happen is we've loaded up the data. We want to look at it. Now, by looking at the data set, we can see that there are a bunch of companies which have different ownerships in a lot of these fields. And you're interested in one particular one. I want to look at, let's say, Shell or BP. But the challenge is that Shell might have a bunch of different entities, legal entities with slightly different names. But as long as Shell is present in the name, I want to isolate all of those and create a new data frame called Shell. So the way you do it is, say, take your data frame, pipe, filter, and then you use a command called string detect, what column you want to run it on, and what pattern or what string do you want to search for. So we run that. We run this command, which produces the filtered data set, and we assign it to a new data frame called Shell data frame. Similarly, we can do that for BP. So now we have two data frames, one for Shell, one for BP, and within BP you can see there are a bunch of different companies, which is BP Exploration, Exploration Beta, Operating Company, Alpha, so on and so forth. So it gives you a good way to isolate and filter data. Now, if you'd want to do it for every high-level brand or high-level aggregation of company, it would be quite challenging. So what I can do is I can combine the Shell and the British Petroleum data frame to create one data frame to look at. So we can call this combined, assign it a new value, and when we run that, we get a new data frame with Shell and BP all in one. But it would take me quite a bit of time to do this individually for every instance. But so can we be more smart about it? So when you look at the organization name, if we say, okay, the first part of the name is a good indication of what the company broadly is. So can we, in a systematic manner, just isolate the organization name, the first part of it, and use that for analysis. So what we can certainly do is, again, going back to the equities, equity share data frame, we can add a new column using the command mutate. Mutate allows you to say you have 7 fields. I want to create a new field to it. So in order to filter shell, but maybe is writing shell, which function command can be used. Ramos, could you elaborate on that? So the STR detect can allows you the flexibility of saying by default it'll just do a string match irrespective of case. I think that's your question, right? Whether if the cases are different, what impact does it have? String detect works without case as a limiting factor. So you can say pick up shell and it will do that across all the cases in the function. If you want to do an exact match, you can specify that as well. So you can isolate it based on whatever behavior you want out of it. It's fairly flexible as a function. So what we can do is you can use the bind rows function to combine 2 different data frames. So we had a shell data frame and BP. We bound them together. What bind does is very similar to if anybody has a background in SQL or even just plain Excel. It takes the first data set and literally appends the second one at the bottom, matching the column names. So as long as the column names are same, or whatever column names are same, it will match column for column all the rows between the 2 tables and create a new one. So yes. So we were at mutate. So what we've done is we've asked using mutate, we've created a new column called first space. And what this column is doing is it's trying to locate the first space that has been used in the company's name. And if you look at the data frame now, here's our new column with the first space as a new column added to it. What we are going to do next is we're going to say now create a new column called high level organization brand by cutting out or creating a subset from the organization's name only from 1 to the end of the first space. So if we run that in the system, go back to our variable. Now you can see we've created a new column for SO, Shell, Equinor, BP, so on and so forth. So I think we can have a higher level aggregation more easily. So let's see for all the different high level organization brands who has the most number of investments across UK fields. So what we've done here, and this is, I guess, the power or the beauty of using piping. We've said, take your oil field, your field equity shares data set, group that by the new column we've created called high level organization brand, and then summarize by counting equity that by counting the equity column and then arranging it in a descending fashion. So if we now open up this new data frame that we've created, it will be easier to open it here. We can see a very quick rundown of which company has how many equity investment. Now, granted that this is only showing the number of count, it does not show the value of investment. But if we have access to, let's say, other financial data or data for the value of each well or extraction that is happening from it, we can bring out that data set and run a match and find out attribution for economic value against this. So let's try and do a quick plot of this. Because visuals are always better. Okay. Too big. Let's see. Yeah. That's the big breakdown of by count and individual operators, how it is distributed. Now, the good thing with R is that it allows a very high degree of control and customization ability for different kinds of visualization that you can do. This is something that it's producing out of the box. It gives you a very good high level idea of how, let's say, the market share is distributed. But as you can see, a large part of it is in the first quartile, the first 25% of the participants. And so we can isolate that to make a more, or rather a less cluttered visual or graph of it. On a side note, I think we had a bunch of other examples that probably would walk through and make a better sense of the different visual capability of R that we can work through. So it's a quick run through of ggplot as a capability. So let's go through the website for so ggplot stands for the GG part of it, stands for grammar of graphics. I think what it very elegantly allows to do is break down graphing capability into different components such that you can describe what's happening with data and what needs to happen with the visualization layer in two separate parts. Here's a quick cheat sheet that I've pulled up, and the basic idea of ggplot, and I think it has then permeated into a lot of other graphing logics, is the same idea of let's separate data which go into making a geometric form or aesthetics, which are then projected onto a coordinate system. And depending on the data and what geometric assignments you're making to it and what coordinate system you're providing, your plot would be created. So it could be like a simple it could be a simple scatter plot where you've provided X and Y values and that's it. Or it can be, you can start going more in depth by saying, okay, X and Y are two values, but the color grading or size of the aesthetic, whether it's a image or shape, is dictated by a third variable, and it can start creating a very powerful or an impactful graph very easily following this logic. I know words are hard to understand, so let's work with a live example. What we're going to do is create a random data set of production values using random numbers. And that will help us create a production profile of sorts. So where's this? Could not find function. So let's walk through the piece that I have highlighted. What's happening here is we're creating a plot where table is a data frame, and we are providing that as a starting point to R, saying this is the data set we want to work with. AES stands for aesthetics, and within the aesthetics function, you provide what is your X, Y, your other values within it. Usually, ggplot ships with smart enough capabilities that it'll pick up and create a good default set to work from. If you want, you can, or if you want to be more specific or the data set is ambiguous, you can provide more direct instructions using the AES function call. And then we start building on top of that ggplot function. So we've said, create a plot using this data, use a light theme for creating the chart. On that chart, plot a density function with a smooth geometric smooth geometric line. Make it the color orange. Do not show me any, show me a legend and do not provide any padding. And then on top of that, you can start getting more articulate, which is the power of R, that you can provide all of these small controls on how your graphs and charts look directly as a program, instead of having to click and manually adjust a lot of these numbers. So we're saying for labels, make it a percentage format with one level of depth, and make the breaks like bin the axis in 10 equal parts. So just allowing for a much finer control of how things look, using things like labs, which is a short form for labels. You can provide a title for the graph. You can provide for what you want to call the x-axis, what you want to call the y-axis, and how it would come across. Let's see where our chart is. So you can see here the table function that we called. It's a fairly chunky table. It has 1 million rows, and it's ggplot as well as the data frame is going through all of that to render and create the chart, which is why it's taking a bit of time. Let's clean this. So. Let's give it a minute. I think the CPU is not able to take this. I just need to refresh. So we can use this time for any questions we have. Hello?
Yeah. So any questions coming? I'd just say Sarang, I've set up a new GitHub so we can post stuff to that afterwards. But I've invited you to it, and then we can share it on Discord for everybody so they can go through this information.
Okay.
Quite at the time. Anybody else want to well, if there are no questions, what about some comments, or you don't just put any remarks you have about your first introduction to R, if it is. Oh, here's one. What is percent greater than percent? That's a question, Sarang. That's just to do with the can you see that question?
I don't, but I'll explain what it is. So the percent greater than percent is a piping operator. It is a way of providing the next step of a command. So generally when you're writing functions or when you're using functions on any language, let's say if you want to create mean of a variable, the standard way of going about it is typing in mean, open brackets, and then passing the values that you want to run the mean for inside it. Now, let's just call it C, 1, 2, 3, 4. So if we run this.
Have you cancelled that plot? I know a big unrisked DT.
Yeah, no, I think that's what it's not letting me.
No, yeah.
Removing the plot and cleaning up the engine.
Oh, just one on ggplot versus plotly. Do you have a particular view as to which? I think you prefer ggplot. I think I probably.
Well, actually, I prefer both of them. Plotly is also very good. The challenge with plotly is it's a commercial implementation. So, at least for the R side, you can bring in almost all of the objects of plotly. There is a integration which allows you to make ggplot objects show up in plotly framework. So both are equally good. I think ggplot is a lot older in terms of its history. I think plotly is something that's come about quite recently, and plotly is more like JavaScript implementation of what ggplot used to do or provides as a framework. But no, both are good, and depending on where you're trying to use it, like if it's a web or an interactive platform, plotly is very attractive. It looks very sleek. But if you're doing something which is for publication, ggplot allows you fairly good level of control and articulation of how well program or how well the chart comes out.
Okay, thank you. Yeah, I know the answer to the question, but yeah, plot you can put Plotly into Shiny in the normal way.
So hopefully this should be a lot faster this time. Coming back to the piping operator. So the piping operator is effectively a pointer which says take whatever is on the left hand side and then pass it as an input to the right hand side. So here we are saying, let's take an example of this particular data that we are working on. We said mean is there, plot comes together. So this is a fairly complex plot, as you can see. What it is doing is it's taken a simulation of 10,000 runs using production profile, and then on top it has calculated your P90, P50, and P10 values, and created your vertical lines dependent on where your P90, P50, and P10 values are. So as your data updates, a chart like this can update in real time, or effectively without having to create this manually and typing numbers. So it gives you a high level of control for creating good charts right out of the box. So the piping question. So first thing is we can do a mean call by saying mean and then providing all the numbers that need to get that need to be considered for the calculation. Now, when you're doing this across multiple steps, it becomes an inside out process. So if you want to take a large data set, let's say if we go back to let's create a data set. Let's create an object SB, which is a data frame, has column A, which equals a sequence of numbers from 1 to 1000. Oops, let's just grab a data frame that we have here. So we have this data frame, and when we want to run any operations on it, so here we've said take this data frame TBL, apply a function for on a row-wise basis, then summarize all of them, which is running unlist. So open up, because each cell has 100 values. So you want to, instead of one cell being an array of 100 values, you want to create 100 cells. So you're unlisting it and then unnesting it so that you get one big expanded table. So previously, where we had just 10 values, now you have a table with 1,000 entries. Now, so if you would have written this as a regular function, what happens is you start with unnest, then go into unlist, then list, then summarize, then row wise, and then the innermost is the table. So your journey of writing the function starts at the outermost, and then you go in and specify each thing within. With a piper or with a piping operator, you start with your data and then pass it down into different values. So you can think of table pipe row wise is doing the same function or the same work as row wise, and then TBL or TBL would do. Now, if you have summarize, you go back and write it outside. And now if you want to unnest, you go and write that even further out, just as an explanation. So if you run this, it's not going to do anything because it's incorrect, but conceptually, this is what happens in a normal function, that you start, your last function is the outermost and your first function is the innermost, which when you're reading the function makes it difficult. Whereas if you're writing it as a piping operator, it's much more natural, saying, okay, take a table, make it row wise, then summarize everything, then unnest everything. Hopefully that answers the question. So
I think it answers the questions very comprehensively. There's Alexandra Makanu is saying, is giving the analogy in Python. So it's Python ds sort by xy mean.
yes, similar.
Yeah,
similar.
Okay. So Sarang, I'm just got a little bit conscious of the time that.
Yeah, I think we are at the end of it.
Okay.
I think we've covered all of the aspects of wrangling data in data frames and getting to the ggplot. I think the next sessions, keeping in mind that we're actually running through a fair bit of examples, we'll schedule it for a longer amount of time rather than just an hour. So we get time to cover things properly, because it would be more advanced, as well as it will cover a huge range of topics.
Yeah, I mean, that's great. Well, we can always adjust that to 2 hours or something, whatever. But ultimately, whatever you think you can take, and also to an extent what the audience think they can absorb. We're actually down to roughly half the people who would join. So I suspect partly that's because it's in Europe, it's 7:15 now. But Sarang, I have to say that was really brilliant. And speaking as one, I'm a real fan of ours, you know, but really so helpful. To everyone else who's still on the call and those who were here will obviously correspond with you. We'll put something on Discord. So please, if you've not yet got yourself on Discord, get on with it, because we'll put some links to the code that Sarang's developed here, and one or two of the databases. Sarang, that database that does the plot is a huge piece of work. So maybe reduce N to, as you say, it makes it reasonable. And then we'll start to post code onto GitHub, and maybe we'll do the same for Python under a different thing. But I've just put together a GitHub, and that will be where you can all gain your access. We'll give you a link to that in Discord. Any final remarks from you, Sarang, before we then finish? I need to talk to you afterwards anyway, but anything else that anybody wants to add? Or Sarang, do you want any closing remarks, or are you done?
Yeah, no, the closing remarks are just that we are available on Discord. There's a Discord server called Bootcamp-R. So if you have any questions, post it there. We'll make a copy of the scripts and links to the data available there. And if if there are persistent questions around certain aspects that need more answering, we can probably do a targeted session or just a bunch of material around that, which can be posted onto Discord.
Yeah. One thing I think, was it clear from your presentation, maybe I wasn't paying attention, was how to download and install R and...
Yes, the details of that are posted on the Discord server on the Bootcamp.
That's fine. Okay, right. Okay, well, thank you very much, everybody, for hanging on in there. And I really hope that you see the extraordinary power of R. It's so cool, so easy to do really, really sophisticated things. And as I say, it's and Python, but there's R for you. And hopefully look forward to seeing you at the next R presentation. Good night to you all.
Thank you.
All right. Oh, we'll log this one.